Hello guys and welcome back. In this video I wanted to explain how to use displacement and apply that in the shader and how to control it in Mantra. So I have a simple scene here with an empty shader at the moment. So let's create a diffuse. Actually, let's just use the principal shader core. And I'm going to connect the BSDF. Just need some diffuse and some reflectivity, and let's assign this to the object. Hit render. Cool, that's our statue rendering, and we want to add some displacement to this. So let's dive inside, and here this is where we need to plug in the displacement information. What it needs, what we need to provide is the new surface position and the new normal. And I'm going to create a noise map, and I'm going to use the position. And as usual, I'm going to bind export it as a separate AV so I can look at it. I'm going to call this CD. Let's go to the render. Make sure we have an AOV for that. Let's create a new AUV and call it CD. So when we render this, we should be able to debug that data. Cool, so that's our noise map. And let's dive back in. Let's increase the frequency. And let's say we want to use this as the displacement. What we need is we need a displace along normal node. And we need to feed in the surface position, the normalized normal, surface geometric normal, the normal vector, and this is going to be our displacement map, which is the displacement amount. And as you can see, it has two outputs: displace P, and displaced normal. And if we look at here, you see now it's saying creating displaced geometry, and Mantra is now dicing the geometry. It uses the micropolygon to algorithm to dice the geometry and render it. So it's going to subdivide each one of them into mini triangles, and we're going to get some cool displacement. Cool, so that's displacement, and you can see the map, the geometry is changing. It's not just normals. Okay, so that's how you do displacement. Let's reduce the amount. And you will see that every time you change this, it needs to regenerate, creating displaced geometry, because it takes the given geometry, dice it, displace it, and then stores that in memory, and it can render it. So this is for displacement. If you have any maps or anything, you can add that. You see, there's a lot of cool details. Okay, and then we also have bump mapping. And with bump, the only difference is that there's two differences. It's not going to change the points. It's not going to push or pull the points. The points will stay the same. We're only going to change the normals of the mesh. So by default, displacement, true displacement is turned on. So anything you do here will be automatically treated as displacement. What we need is to do just bump mapping. We need to tell Mantra not to do true displacement. And the way to do that is by creating a node called properties. It's empty by default. And this is how, with this node, we can attach extra rendering properties. And we're going to go under the edit rendering tab, and we're going to search for one called true displacement. True displacement. Let's drag that in, hit apply. See, the default is on, so I'm going to turn it off, and I'm going to hit render. And now you can see the silhouette is back to its original, but the normal are still being modified. And if we hit render again, you see there is no displacing geometry. It's only creating this geometry, and it's much faster. So this is how we do bump mapping. If we wanted to add anything to the geometry, we can do that. Let's reduce the amount, maybe 0.05. So increase the frequency 10 by 10 by 10. Cool. So the next thing, we'll do that in the next video. So this is how we do displacement and bump mapping onto the geometry. Thank you for watching, and see you in the next video.